Hello everyone. In today's video we are going to understand what is differentiation actually. Okay. So differentiation, sometimes also known as a derivative, is today's topic. How to find derivative of a function. Yes, derivative of a function. Derivative of a function, or you can say differentiation of a function, can also be called as derivative derivative, not derivation, derivative or differentiation of a function at a point in its domain. Okay, so what actually this derivative or differentiation is? So before we answer this question, let us understand its importance. So this differential calculus, which is related with derivative or differentiation, it is the mathematics of change and of infinitesimals. Infinitesimals means very small numbers or very large numbers. Okay, so this is a mathematics of change involving infinitesimals. That is the right way of saying that. You might say it's the mathematics of infinitesimal changes that occur every gazillionth of a second. So basically you are trying to understand, calculate, and analyze the changes which occur at the smallest possible interval of time. Without this differential calculus, you have just got algebra, geometry, trigonometry, and you're limited to the mathematics of the things that either don't change or that change or move at an unchanging rate or at a constant rate. Okay, so that's not how things are in reality. In real life, you see things which are changing constantly. You see things which are you can say constantly evolving. So if that is the case, if things are constantly changing and at not a constant rate, you can say at a variable rate, then your normal algebra, geometry, trigonometry will not be of much use. So like you have this problem, you have this question in physics or wherever, in motion maybe. One train leaves the station at 3 p.m. going west at 80 kilometer per hour or miles per hour, whatever you want to take. 2 hours later, another train leaves going east at 50 miles per hour. You can handle such a problem with algebra because the speeds or rates. What is speed actually in this question? Speed is the rate of change of distance with respect to time. The difference in distance with respect to time is the speed, but the speed is constant, right? So in this problem can easily be solved using the formula speed is equal to distance upon time, and you can get the answer. But generally the problem in real life, the problems are not as simple as this one over here. So in the real world, when you use the calculus has so many applications. Among the disciplines can utilize calculus including physics, engineering, economics, statistics, medicine, and so many more. Calculus, or you can say differential calculus, it is used to create mathematical models in order to arrive into an optimal solution. For example, in physics, calculus is used in lot of its concepts. Among the physical concepts that use concepts of calculus include motion, electricity, heat, light, harmonics, acoustics, astronomy, dynamics, also thermodynamics. So All these topics of physics we are going to study in class 11th and 12th, which use calculus. In advanced physics, concepts including electromagnetism, Einstein's theory of relativity, they also use calculus. In field of chemistry, calculus can be used to predict functions such as reaction rate, radioactive decay. In biology, it is used to formulate rates such as birth and death rates, or rate of growth of a particular virus in an environment like the virus we are dealing with right now. That can also be the rate of the growth, or you can say decay or decline of that virus can also be found using calculus, can be estimated using calculus. In economics, calculus is used to compute marginal cost and marginal revenue. So we are not students of economics. We don't know what these terms mean, but we definitely know calculus finds its use in economics as well. Enabling in economists to predict maximum profit in a specific setting. In addition, it is used to check answers for different mathematical disciplines such as statistics, analytical geometry, and algebra. So these are the uses of your calculus. Also, most of these uses are related with our differential calculus. Okay, that's our today's topic. So let's get um, to the point, that is, what is a derivative. Derivative is nothing but a slope. You know what is a slope, right? Most of you know what is a slope. So derivative is, it is nothing but slope. So suppose if I have a function, let's say y is equal to x. You know what is this function? This is identity function. Okay. Also, you can say that this is a linear function because there is no power of x. Power of x is 1. That's why it's a linear function. So the graph of this function will look like, the graph of this function will look like somewhat like this. Okay, so this is the graph of the function y is equal to x, identity function. So what is the meaning of this function? This function tells us that there are different values of y for different values of x. So there are different values of x here on the x-axis. For respective x values, there are different values of y. But always the case is, whatever the value of x will be, the same value will be of y. That's why this is an identity function. So suppose this value is 1, so here will also be 1. If this is 2, this will be 2. If this is 3, this will be 3. If this is 4, this will be 4, and so on. So these points which you see on the graph of identity function, they are having the coordinates of 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, and so on. So why I'm taking this example is I want to just show you that any linear function, this is an identity function, the simplest kind of linear function. But if it is any linear function where the power of x is 1, where the degree of x is 1, in that kind of linear function, the graph will always be a straight line. You all have studied uh, simultaneous linear equations, or you can say linear equations in two variables. So these functions which we are talking about are ideally the linear equations in two variable, and the word linear is the most important. Two variable it has to be, because we are dealing with two variables, one of which is domain and the other is range. X is domain and y is range. So y can also be written as, it will be accurate to write y as f of x. Y is equal to, so y is a function of x. So whenever y is a function of x in a linear equation, where the relation between y and x is a linear relation, where the power of x is 1, you get the graph of such a function as a straight line. And do you know how to find the slope of such a graph, which is a straight line? Yes, you know. If you don't know, if you have forgotten, I will tell you the formula. So the formula for slope, which now will be called as a derivative, okay? Derivative or slope of what? Of a function. And what is this function? What function are we talking about here? This function is a linear function. Linear function means the power of x has to be 1. The simplest type of linear function is the identity function. But it could be y is equal to 3x, right? Or y is equal to x plus 3. Doesn't make any difference. It's still a linear function. So slope of a function or derivative of a function which is linear in nature is equal to, it's equal to, for a linear function the formula is rise upon run. And I don't know how many of you are you can say familiar with this formula rise upon run. If you are not, I can give you the accurate formula, mathematical formula, which is used in your textbook. So rise upon run, it deals with uh, the vertical distance in the numerator of the quotient of this fraction, and the horizontal distance in the denominator of the fraction. But what is this horizontal and vertical distance actually? Let's have a look at it from the graph. So what we do is we select 2 points. Suppose we select this one point A and another point here B. Any 2 points, okay? On a straight line, to find its slope, we can select any 2 points. And what we can do is we can draw a vertical line like this, vertical perpendicular line to x-axis, and horizontal line parallel to x-axis or perpendicular to y-axis, right? So these will make an angle of 90 degrees. So this distance which you see is the rise, and this distance is run. Okay, now how to find this rise? So for that I would want you to tell me what are the coordinates of point A. Let me make it little, yeah. So what are the coordinates of point A? Let the coordinates of point A, here the coordinates are 4 comma 4, but let us assume that the coordinates of point A are x2 and y2, and the coordinates of point B are uh, x1 and y1. So can you tell me how to find this? Suppose this point is C. Can you tell me how to find the distance AC, which is the rise? Okay, so this distance AC, which is the perpendicular distance between point A and B. AC is the perpendicular distance between point A and B. And perpendicular distance can be found using by subtracting the y coordinates of point A and B. So y coordinates of point A is y2, y coordinate of point B is y1. If you subtract their y coordinates, you will find the perpendicular distance between any 2 points, that is AC. So y2 minus y1 is the rise. What is rise? Y2 minus y1. What is the run? Run, that is the horizontal distance between 2 points A and B, can be found by finding the length BC, and length BC is nothing but the horizontal distance between A and B. So the x coordinates of B and A are x1 and x2. Subtract them, x2 minus x1. That gives you the run. So now you have got rise upon run, y2 minus y1 upon x2 minus x1. But you know what is the beauty of a linear function like this? Linear function has got its slope constant everywhere or anywhere on its graph. The slope, let me write this down, you can also note it down. The slope of a linear function, the slope of the graph of the linear function, the slope of a graph of a linear function, the slope of the graph of a linear function is constant for any two points on the graph. Means the graph of a linear function has a constant slope. What do you mean by constant slope? That means the derivative of a linear function at a point is always the same. So you find derivative using 2 points, you find derivative using other 2 points, or a single point maybe. You will always find the same value. So it doesn't matter which points you are considering for finding the derivative. If it is a linear function, then your derivative or the slope of that function at a point will always be constant. So here it does not matter that how you are finding the slope. You are using calculus or you are using algebra, that is y2 minus y1 upon x2 minus x1. Doesn't matter. For linear function, that's not a problem. And that's what we were talking about. You remember, I told you at the beginning of this lecture that things which do not change or things which change at a constant rate are very simple to deal with. With simple algebra geometry, you can deal with that. But in real life, we are not going to deal with only linear functions. We are going to deal with complicated functions. So what are these complicated functions? So I'm going to give you some examples of functions whose slope of the graph is never constant. Example of functions whose slope of their graph is never constant. Okay, that means their derivative is also never constant. That means their derivative is continuously changing. Their differentiation is continuously changing. How to deal with such functions? You cannot use algebra. And examples of such functions are uh, quadratic functions, quadratic equation. You know quadratic equation, right? Quadratic equation has the degree 2 for x. Cubic functions whose degree is 3. Then quadratic, cubic, and then reciprocal functions. Exponential functions, logarithmic functions. All these functions which are so useful to us, they are all having slope as a variable quantity. So slope is always changing because these functions are not straight lines on the graph. If you see their graphs, which we have already discussed, they are never straight line. One more important function, trigonometric functions, which we are going to study. Their graphs are also curves, not a straight line. So their slopes are ever changing. Inverse trigonometric functions. So these are just a few examples where we are going to find the graphs in not in a straight line. their graphs will be curves, and where the graphs are curved lines, the slope will never be constant. So all these functions have their graphs are not straight lines. Always remember. Okay, so if you believing that you are going to deal with just linear functions, then you are wrong. We dealt with linear functions up to class 10th, but now we are going to deal with these functions. And not just solving quadratic equations, or you can say exponential function. No, we are going to now look at the problems involving the change of the value of these functions as the domain changes. That is what derivative will teach you, right? So the next big idea of derivative is, the first thing which I told you about derivative is derivative or differentiation. This both words are same, okay? Derivative or differentiation of a function is its slope at a point. Now this is also very interesting. When I say derivative or differentiation of a function is its slope at a point, you would be surprised to know that, you would be shocked to know that in algebra, we cannot find derivative of a function at a point. We need 2 points to find slope. In linear functions, in case of linear functions, we cannot find derivative using a single point. There also we need 2 points. But in differentiation, since at every point the slope is different, so we have to find the derivative or differentiation of that particular function at a point, at a single point. And that's what derivative does for us. In algebra it's not possible, but with derivative it is possible. With differentiation, with calculus, differential calculus, it is absolutely possible, and that's what we have to understand, that how it is possible, right? So the first big idea is, what is derivative? Derivative or differentiation of a function is its slope at a point. Second big idea is derivative of a function is the rate of change, is the rate of change. So we have to understand now what rate of change is. Okay, see, derivative, the symbol of derivative is dy by dx, dy by dx. It can be also written as d by dx of y. It can be also written as d by dx of f of x. Now what is this dy by dx? It is actually, it has been you can say it has found its use, or it has found its application from this delta y by delta x. Now here this d and y are not in multiplication, okay? D means delta. D means delta. And what does delta mean? Delta means change. Delta means change. Okay. And this delta has found its use from change in y. Okay. So delta is change. So change in y. That is y2 minus y1 upon x2 minus x1. Now you must be thinking that, okay, we know this formula because we have just discussed it and we have used it earlier. This is the formula for slope. Yeah, so that's what. From formula of slope, this delta y by delta x was written, and from delta y by delta x symbol, this symbol was made. Okay, but what does it actually mean? See, I am trying to tell you that derivative or differentiation of a function is its slope at a point, but it is also known At a bigger picture, if you see, it is also known as the rate of change. So derivative of a function is the rate of change of that function at a point. Rate of change of a function at a point. Rate of change of a function at a point. Okay, so that's what the difference is. How you can find that how the function is changing at a point. Okay, now just let me tell you the meaning of this thing. What does this mean? D by dx of y or dy by dx. This tells you the rate of change of y with respect to x. Means it tells you how much your y changes when x changes. How much y changes with respect to x. How much change is brought in y with respect to x. What is the change of y with respect to x? That means when you change x, what is the change in y? Correct? So what is y basically? Y is nothing but your range, and range can be written as f of x. See? So you can write it, you can say that derivative of a function is rate of change of f of x with respect to x. So rate of change of the range with respect to the domain is the derivative, or the differentiation of a function at a point. That's what you need to find. Now you're getting it. Are you getting it? So now we are going to connect two huge topics which we have studied up to now. First topic which we have completed is limits. How we can use limits to find the rate of change of a of f of x with respect to x. How we can find limits, how we can use limits to find the rate of change of a function at a point, or how we can use limits to find the slope or derivative of a function at a point. ठीक है, अब ये सब चीजें आई थिंक तुम्हारे माइंड में काफी क्लियर हो चुकी है कि क्या है डेरिवेटिव, यही तो है डेरिवेटिव. तो इसका अच्छा और एक बात मैं बता देता हूं, इसका प्रैक्टिकल यूज क्या है. अभी तुम्हारे माइंड में ये क्वेश्चन आता रहेगा कि व्हाट इज इट्स प्रैक्टिकल यूज, ये सब क्यों बता रहे हैं आप, व्हाट इज इट्स प्रैक्टिस. ठीक है, समझ गए. चलो पहले आपने बताया कि स्लोप होता है रेट ऑफ चेंज, और लीनियर फंक्शन का स्लोप हमेशा कांस्टेंट होता है, लेकिन हमें रियल लाइफ में ऐसे फंक्शन पढ़ने हैं जिसका ग्राफ स्ट्रेट लाइन नहीं होता है, इसलिए इसका स्लोप भी कांस्टेंट नहीं होता है. और उसका स्लोप हम कैसे ढूंढते हैं? बाय फाइंडिंग इट्स डेरिवेटिव. ठीक है, लेकिन एक रियल लाइफ एग्जांपल तो दो जहां पे हम लोग डेरिवेटिव ढूंढ सके. ओके, मैं देता हूं तुम्हें रियल लाइफ एग्जांपल. एग्जाम्पल मैं तुम्हें दे रहा हूं, बहुत ध्यान से समझना है इसको. एग्जाम्पल है फ्री फॉल का. फ्री फॉल का एग्जाम्पल है. ठीक है, अब फ्री फॉल में जस्ट इमेजिन यू आर फाइंडिंग और यू आर ट्राइंग टू अंडरस्टैंड अ रिलेशन बिटवीन distance covered and time taken. Suppose you are finding the relation between distance covered and time taken in free fall. सबको पता है फ्री फॉल क्या है. फ्री फॉल क्या होता है? फ्री फॉल का मतलब होता है कि जब कोई भी बॉडी को ड्रॉप करते हैं एक सर्टेन हाइट से, तो वो नीचे गिरता है. अब क्या वो यूनिफॉर्म वेलोसिटी से नीचे गिरता है? बिल्कुल नहीं. बिकॉज दिस फ्री फॉल इज नथिंग बट fall of a body under the effect of gravity. What is gravity? Gravity is the gravitational pull exerted on any body by earth. The fall of a body under effect of gravity is the free fall. And you know that whenever a body falls freely, it is acted upon by acceleration due to gravity. It undergoes acceleration due to gravity. ठीक है, तो यहां पे एक्सेलरेशन इन्वॉल्व है। ठीक है, सो लेट्स फाइंड अ रिलेशन बिटवीन डिस्टेंस कवर्ड एंड टाइम टेकन। अच्छा, फॉर सिंप्लीफिकेशन आई विल टेक माई डिस्टेंस as y and I will take my time as x because these two quantities they matter, right? यही दो क्वांटिटी है जो मैटर कर रही है, दैट इज डिस्टेंस कवर्ड एंड टाइम टेक। ठीक है, हमें इनके बीच में ही रिलेशन ढूंढना है। तो टाइम को मैंने x लिया है, इसका मतलब क्या है? व्हाट इज टाइम? टाइम इज माय डोमेन। एंड डिस्टेंस को मैंने y लिया है, y क्या है? f ऑफ x। इसका मतलब क्या होता है? रेंज। सो y is my f of x. So basically after every second what is the distance covered? What is the outcome? If I put the value of x as 0, there of course the distance will be 0. If I put the value of x1, what will be the distance? If I put the value of x2, what will be the distance? We are trying to find that out. सो लेट्स फर्स्ट एक एल्जेब्रिकली इसका रिलेशन हम लोग ढूंढते हैं। ठीक है, फिर ग्राफिकल में जाएंगे, फिर स्लोप में आएंगे। ठीक है, रियल लाइफ एग्जांपल से पहले बात करते हैं, फिर धीरे 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 थियोरी में जाएंगे ताकि तुम्हारा ये कॉन्सेप्ट क्लियर रहे। ऑलराइट, सो डू यू रिमेंबर दिस फॉर्मूला? S is equal to ut plus half at square. This formula can be transformed for free fall as h is equal to, see, u is initial velocity which is 0, so this will be 0 into t which will become 0. So directly we can write half gt square, right? So this formula will be transformed. Now we know the value of g, we can take it as 10 for simplifications. Okay, so this will be h is equal to 5t square. Now I told you I will take the distance covered as y or f of x and time taken as x. Okay, so h is the distance covered, so I will take it as f of x is equal to 5x square, or let me take it as y is equal to 5x square. Now do you see the relation between distance covered and time? Is it a linear relation? Now tell me, is it a linear relation? Absolutely not. So what relation is this? This is a quadratic relation. It's a quadratic function. The function which you have just got is a quadratic function because degree of x is 2. So in this case, how we can find the derivative of this function? Now what is derivative? Derivative is the rate of change. Okay, so derivative, let me write it. Derivative of y is equal to 5x square is the rate of change of y. What is y? Y is the distance with respect to x. X क्या है? Time. So what is the derivative of this function? Derivative of this function is rate of change of distance with respect to time. Now can you tell me what is rate of change of distance with respect to time? What is the change of distance with respect to time? So change of distance is distance covered and change of time is time elapsed. And what is distance covered upon time equal to? That is the speed or velocity. So the derivative of this function is nothing but the speed. In this case, we have to find the speed. Okay, but remember, मैंने जब भी तुम्हें डेरिवेटिव का पूरा पहले से मैं बताते आ रहा हूं, मैंने जब भी डेरिवेटिव का मतलब बताया है तुम्हें, आई हैव टोल्ड यू वन थिंग वेरी क्लियरली। ठीक है, डेरिवेटिव of a function is always found at a point. Derivative or differentiation of a function is a slope at a point. ठीक है, तो मुझे स्पीड एक किसी पॉइंट पे ढूंढनी है, और वो पॉइंट किस पे होना चाहिए? उसकी डोमेन में, और अपना डोमेन क्या है? टाइम। मतलब speed at a given time. ठीक है? When we find, let me write this, when we find, therefore when we find derivative of y is equal to 5x square, when we find the derivative of y is equal to 5x square, we will get speed of freely falling body at a given time, at that given time actually. ठीक है? When we find the derivative of y is equal to f of y is equal to 5x square, we will get the speed of a body, freely falling body, at a given time. At a given time बहुत जरूरी है, क्योंकि क्या हो रहा है पता है? When the body is covering uniform, when a body is undergoing uniform motion, क्या हो रहा है? What is happening? You can find the speed at any point of time. जैसे अगर बॉडी ऐसा कोई डिस्टेंस टाइम ग्राफ एग्जिबिट कर रहा है, इसको डिस्टेंस टाइम ग्राफ ही मान लो, एक्स एक्सिस पे टाइम है, वाई एक्सिस पे डिस्टेंस है, उसका स्पीड ढूंढ सकते हो तुम, हाँ, क्योंकि स्पीड कांस्टेंट है. The rate of change of distance with respect to time is constant. The slope of this function is constant. So we can use algebra y2 minus y1 upon x2 minus x1. But do you know how the graph of this function looks like? हमने ये सब पता लगा लिया कि ये जो डेरिवेटिव है, डिफरेंशिएशन है ऑफ अ फंक्शन, इन रियलिटी, in actual cases, it is mostly related with graphs which are not straight lines like this free fall. ठीक है? इसका ग्राफ कैसा है पहले ये देखते हैं. So this is the graph of y is equal to 5x square. This is the graph, the, you can say, distance time graph of a body which is freely falling under the effect of gravity. ठीक है? Is it a straight line? Absolutely not. It's a curve. ठीक है? तो ऐसे ग्राफ का स्लोप मुझे किसी एक पॉइंट पे निकालना है, तो मुझे कैलकुलस की जरूरत पड़ेगी. ठीक है? विदाउट कैलकुलस आई कैन नॉट फाइंड इट स्लोप. ठीक है? एंड दैट्स व्हाट आई एम ट्राइंग टू टेल यू. व्हाट इज द यूज ऑफ कैलकुलस, व्हाट इज द यूज ऑफ डेरिवेटिव. ठीक है? मुझे किसी एक फंक्शन का ग्राफ तो मिल गया, लेकिन मुझे समझ में आ रहा है कि ये ग्राफ तो कर्व है. ठीक है? अगर ये ग्राफ कर्व है तो हाउ कैन आई फाइंड इट स्लोप एट अ पॉइंट. ठीक है? बिकॉज आई कैन नॉट यूज एल्जिब्रा एट एवरी पॉइंट. एट अ सिंगल पॉइंट पहली बात तो एल्जिब्रा का यूज ही नहीं होगा. एक सिंगल पॉइंट पे मैं स्लोप निकाल ही नहीं सकता. स्लोप निकालने के लिए तो मुझे दो पॉइंट चाहिए, और यहाँ पे हर एक दो पॉइंट का स्लोप अलग है, because it's a curve line. So how do I proceed? How do I go ahead? That's what we have to learn in this part. Okay, so now you understand whatever I have told you till now. I have first started with what is differentiation or derivative of a function at a point. क्यों इसका हमें ज़रूरत पड़ता है, इसका रियल लाइफ में क्या क्या एप्लीकेशन है. एंड देन आई स्टार्टेड बाय एक्सप्लेनिंग यू द एक्चुअल मीनिंग ऑफ डेरिवेटिव. डेरिवेटिव ऑफ फंक्शन इज अ slope of that function, slope of the graph of that function. And the functions whose slope of the graph is never constant are the functions which we always come across in our day-to-day lives. And for example, the derivative of such a function is its slope at a point which can never be found with the help of algebra. Okay? That is, the symbol of this derivative is d by dx of y, or dy by dx. That is rate of change of y with respect to x. Okay? And I gave you a very you can say valid example of free fall, where we saw the relationship between distance and time is not linear. It is a quadratic relation. So the rate of change of distance with respect to time, that is the speed, cannot be found with algebra, cannot be found using algebra, right? So how can we find it? Speed of a body at any time can be found using the derivative, that is finding the derivative of this function at a point, or finding the slope of this function at a point, that will give us the speed of the freely falling body at any given time. ठीक है? So let's go ahead and understand के how to connect derivative with limits. Big concept. So here is a graph of a linear function which is showing the slope at different points. So as I told you, the slope of any function is equal to rate of change of y with respect to x. Here this is x and this is y, right? That is how fast, you can say, how fast is y changing with respect to x. That's what we can find out with the help of slope. And since this is a straight line, we can find slope very easily. So first we consider these 2 points, and then we find the rise and the run. So rise upon run, that is 2 upon 1. The slope is equal to 1. Sorry, 2 upon 1, the slope is equal to 2. If you take this point and this point, again the slope comes rise upon run. Rise is 2, run is 1, so slope is again 2. So what does it mean when we say that slope is 2? That means that y is changing twice as fast as x, right? Or we can say that y is equal to 2x. Y is equal to 2x, or L is equal to 2h. That's one and the same thing, right? And if you compare this equation with y is equal to mx plus c, you know what is this? This is the slope intercept form of a straight line. So in that, the coefficient of x, that is m, gives you the slope. And here the coefficient of x is 2 and the slope is also 2. That's not a coincidence. This is an extension of coordinate geometry which you have studied already. Correct? So here it's very easy. The deal for finding slope is very simple, straightforward. But then when a curve comes, what happens? This is what happens with a curve. At curve, for curve, the slope at different points is different. So slope at every different point is different. And what is it? See, if we consider this point 6 comma 9, what is the slope at 6 comma 9? So of slope of the graph at a point. Okay, remember that you cannot have 2 points for finding the slope of a graph. For a line you need 2 points, and you have 2 points, but for a graph you cannot have 2 points. So you have to find slope of the graph for a curved graph, for a graph of a curve. Maybe you can say graph of a function which is a curve. If you want to find the slope of this kind of graph at a point, then you need to find slope of the tangent, to the curve at that point. So at that point, you need to draw a tangent. You know what is a tangent? Tangent is a straight line which touches the curve, any curve, at a single point only. So do you see there are tangents drawn to the curve at different points? So what you need to do? You need to find the slope of the tangent to the curve. Now as you can see, the slope of the graph at this point 6 comma 9 is the slope of the tangent, and the rise and run are visible. So what is the slope at this point? Slope is equal to 3 by 1, which is 3. What is the slope at this point? Slope is equal to 2 by 1, which is 2. Now the slope is smaller at 4 comma 4 as compared to 6 comma 9. So the curve is such a graph that it at every point its slope is changing, right? So that's why we find slope of a graph at a point when the graph is in the form of a curve. And that slope of the graph at a point for a curved graph is nothing but slope of the tangent to the curve at that point, which we are seeing that it is different at different points. What about at this point? What is the slope? The slope is rise upon run, which is 1 by 1. Now the question is, how do we find this rise upon run? Because that's the most difficult part. How do we find it? That seems impossible, right? So there is a method. Now this method which I'm going to discuss connects the concept of limits with finding the derivative of a graph at a point. Okay, so how to use limit to find the derivative? That is what we are going to discuss now. Okay, so we are going to use a concept which is known as the difference of quotients, or the difference quotient. The difference quotient, yeah, not difference of quotient, but the difference quotient. So what is this concept? Let me explain with the help of this graph. Suppose you want to find the slope of a graph at a point. Let's say the point is 2 comma 4. So we are interested in finding slope of, and this the function over here is y is equal to x square. So slope of the function y is equal to x square at 2 comma 4, or at x is equal to 2. What is the slope of this function at x is equal to 2? We are interested to find that. And now when you look at this function, uh, see, algebraically it is not possible to find the slope, but we can understand a few things about how to get to the slope using limits. So what do we do is, starting we start with uh, considering 2 points on this graph. Consider 2 points on our graph, and a graph is a curved line in this case, so we have to consider 2 points on our curved line. Okay, so the first point must be, first being 2 comma 4. The first point must be 2 comma 4, and the second point at a considerable distance, 10 comma 100. It can be any point, not 10 comma 100. I've written 10 comma 100 just because it is at a larger distance, and we can see that these 2 points are farther from each other. You can consider any 2 points. You can consider 9 comma 81, because since this function is a square function, square functions means whatever the domain is, you square it and you get the range. Correct. So you can get 9 comma 81 or 11 comma 121 or 8 comma 64, anything will do, but this is fine. So first is the point at which you have to find the slope. That should be the first point. Okay, now understand, you don't have to do all this when you use derivative. This is for understanding how derivative works. If you don't understand how derivative works, then you cannot use first principles. You will be confused with most of the basic fundamentals of calculus. That's why we are getting into the details of it, and we are not going to discuss it again and again. Rest of the class 11th and 12th, we are just going to use it explicitly, without considering that we are finding a slope at a point or whatever. We are not considering anything. We are not even considering a function. We are just looking at algebraically. But for now, for understanding the concept, we have to do all these gimmicks. Okay. Now observe line joining 2 comma 4 and 10 comma 100. Okay, what I'll do is I'll name this point as P and I'll name this point as Q. Okay, that is PQ. Now what is PQ? PQ is a secant. You know what is a secant? So basically you have a circle or any curve, and secant is a straight line. Secant is a straight line which cuts the circle at two exact points, or which cuts any curve at two exact points. So PQ, as per me, is the secant, right? PQ here is the secant because PQ is cutting this curve, this function at 2 points, that is 2 comma 4 and 10 comma 100. So PQ is a secant. Okay, now we have two coordinates. If we consider PQ, we have two coordinates, that is x1 y1 2 4 and x2 y2 10 100. So we can find the slope of PQ. It's possible to find slope of PQ using algebra, that is rise upon run. Of course you can find the slope of PQ using rise upon run, but is it necessary? Okay, so let's come to that. Now the fifth point which I want to say is, but derivative of y is equal to x square at x is equal to 2, derivative of this function at x is equal to 2, derivative of this function at x is equal to 2 is slope of tangent. Very important thing I'm trying to tell you, slope of the tangent at x is equal to 2, or you can say 2 comma 4. We are not interested in finding the slope of PQ. We are interested in finding the slope of this line. This is the tangent. Let me name this tangent AB. Do you see AB? AB, what is AB? AB is the tangent to the curve at 2 comma 4. And the slope of this tangent, slope of this tangent AB is equal to derivative of y is equal to x square at x is equal to 2, and we are interested in finding the slope of AB at x is equal to 2. We are not finding we are not interested in finding the slope of PQ. As you can see, the slope of PQ is not equal to slope of AB. Is the steepness or slope of PQ and AB same? Can you tell? Can you answer that to yourself? Absolutely not same. The steepness of PQ is more than steepness of AB. The slope of PQ is more than slope of AB. So if we find the slope of PQ and tell, okay, that is the slope of this curve at point 2. No, that is not right. Because we are interested in finding the slope of the tangent at point 2 comma 4. Tangent to this curve. That is the derivative of y is equal to x square, or our function at x is equal to 2. So what is to be done? Now just imagine, I'm also going to show you a you can say animation of what actually we want to do. So in the animation, I will show you exactly what is to be done. But before that, I want you to use your imagination. Just imagine that using limits, we are bringing point Q as close to point P as possible. We are sliding point Q. That's what we did in limits, right? We are sliding point Q as close to point P as possible. So you know how that can be done? By approaching the x coordinate, which is 10, towards 2. If the x coordinate 10 comes closer and closer to 2, That is, if x approaches to, what happens? The x coordinate is decreasing. It is 10 initially and trying to get closer and closer to 2, not becoming 2 but getting closer and closer to 2. Now this getting closer and closer is a very, you can say, you've heard this term. It's a very known term, right? Getting closer and closer, zooming in. And how do we zoom in? How do we get closer and closer to? Infinitesimally close to 2 we have to reach. And that is done using limits. That is done using limits. So I'm going to show that how the, the slope of PQ becomes equal to slope of AB as Q gets closer and closer to P. As this Q slides, just imagine all these things which I'm saying in your mind. Just imagine that Q is sliding towards P. The x coordinate of Q, that is 10, is getting closer and closer to 2. It is becoming 10, 9, 8, 7, 6, and it is getting closer and closer to 2. It is becoming 3, then 2.9, then 2.8, then 2.5, then 2.2, then 2.1, then 2.00001, and it is getting closer and closer to 2. You know what will happen? This secant which you see, PQ, will become coincident with AB, that is tangent to the curve at point 2. Now if you have a little bit of imagination, and if you just imagined what actually happened, now is the right time to show you what actually happened with this. If this works, I don't know if it works. Yeah, secant becomes coincident with tangent. Coincident means it, secant is, you can say, it is lying just on the top of the tangent, and that's what we want to bring them as close as possible to each other. See, two points were separate, but as one of the point was stationary and the other point which was moving, it came as close as possible to the other point. What happened? The secant and tangent became the same line. See, the point is coming closer, secant and tangent are becoming same line, so their slope will also become same. That's what we want. We want the secant to get coincident on the tangent by sliding the point Q towards P, by approaching the x coordinate of point Q towards the x coordinate of point P, that is by approaching x towards 2. We can make this secant PQ coincident, or having the same slope as the line AB, which is the tangent to this curve at point P. And then we can find out what is the derivative, because then limits will help us to find out the derivative. And how to do that? So the whole question is how to do it. Just see this. Okay, so as you can see here in this animation, what is happening? When these 2 points are far away, the red line is the tangent. When these 2 points come closer and closer by sliding the red point towards the orange point, the red line, which was the secant, becomes coincident with the dotted orange line, which is the tangent at the point on the curve. So that's what we want. We want these 2 points to be closer and closer to each other. We want to make sure that the distance between 2 points reduces to an infinitesimal level, becomes very, very small. And this, we will not do, this derivative will do for us. How the derivative will do for us, I will show you now. But as you can see in this animation, the limit of f of c plus h minus f of c upon c plus h minus c, when limit of h tends to 0, this is the definition of derivative. This is the definition of derivative. If we do this thing with the given function, if we apply this limit and we do this thing with this function, we will automatically find the derivative of this function at the orange point. You understand? Now you understand what I was talking about. Now you can imagine or you can relate your visualization when I told you to slide that point Q towards P, so that PQ becomes coincident with the tangent AB. This is what you need to do, so that we can find the derivative or the slope at a point, right? Slope of the tangent at a point on this curve. Okay, so let's do it. Okay, now in this graph, this is the same graph, y is equal to x square, and if you look at the original, see, this is our point P, 2 comma 4, and this was Q, 10 comma 100. Now if you try to bring this Q, slide it and try to bring it closer and closer to P, that is, you reduce or you approach the x coordinate towards the point 2. Okay, what will happen? At the first point, the slope of line PQ is rise upon run. When the Q is at its original position, rise upon run, that is slope of the secant PQ, is 96 upon 8, which is 12. If you bring point Q to point, let's say R, the slope of the secant PR becomes 32 upon 4, which is 8, right? It was the slope when Q, when the point was at point Q was how much? 96 divided by 8, which is 12. When the point Q slid along this curve and reached at position R, the slope of the secant PR, this is slope of PQ. Slope of PR became 32 by 4, which is 8. See, the slope reduced because the steepness of the line reduced. Now you need to bring this point so close to point P, that the slope of the new line becomes equal to the tangent at point. Okay, so this is what we are trying to do. But how? Okay, so what we need to do is this. Pay attention here. We need to find the slope of the tangent by finding the limit of the slope of the moving secant, I'm sorry, such that when the point slides closer and closer to 2 comma 4. This is what we need to find. In other words, we need to find the slope of the tangent, which is equal to the limit of rise upon run when the run approaches 0. When the run approaches 0. Or we need to find the limit of y2 minus y1 upon x2 minus x1 when run means this x2 minus x1 approaches 0. Okay, so let's keep this graph in front of us. This one, no, let's keep this graph in front of us because we have some space also over here. Okay, so let's keep this graph in front of us and understand what we need to find. So basically what we want is, we want this 10, that is x coordinate, to approach 2. That is, we need this 10, that is x coordinate of point Q, to get closer and closer to 2, so that the distance between P and Q reduces. So basically what we need is, we need a point very close to P. Let a point very close or in the bracket I can write infinitesimally, infinitesimally close to, let a point very very close or infinitesimally close to P, which is 2 comma 4, B, B, uh, H comma H comma f of H, H comma f of H. Now you must be wondering, what is this H? So if you look very closely to any point, like if you zoom into this point, in its neighborhood, that is around this point P, around this point 2, there are many small points. Okay, now if you can tell me the number which is little bit bigger than 2 but very very close to 2, it could be 2.000000001, very close to 2, little greater than 2, very near to 2. Okay, so that is this point H which we are talking about. Okay, what is f of H? Now see, this is our x's value, that is the new location of point Q when it slides and comes closer to point P. Now for this location, if I want to find out the value of the range, what would I do? I will put the value of x in f of x, our function, so that I get a range, I get a value of range. The value of that range is f of H. Okay, so what we have done is we have considered a hypothetical point very very close to 2 comma 4 by sliding down point Q towards point P. Okay, so algebraically we are going in the right direction because we have already got one point and we have found our new point. Now let the new point be Q dash, whose x and y coordinate be H and f of H, H and f of H, where H is very very close to 2. Okay, H is very very close to 2. In fact, let me put it this way. H is actually the difference between the x coordinates of P and Q. So you can't say that this point is H. Let me write this point as, let me write this point Q dash as x plus H, that is 2 plus H. Okay, let me write this point as 2 plus H comma f of 2 plus H. This is absolutely accurate. So what is H? H is actually not the coordinate. H is that difference between the point, the x coordinate of point 2 and the new x coordinate, or you can say x coordinate of the new position of point Q, which is now very very close to point P. अब Q ने क्या किया है पता है? ये Q इस पे स्लाइड होते 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 कहीं यहाँ पे आ गया है और अभी उसकी पोजीशन है Q डैश, और ये Q डैश 2 के इतना करीब है कि उसका जो अब x कोऑर्डिनेट है वो मैंने क्या लिया, 2 प्लस एच. एच क्या है? एच बहुत छोटा नंबर है, मे बी 0.00001 है. ठीक है, और विथ रिस्पेक्ट टू दिस पॉइंट व्हाट इज आवर रेंज? The range with respect to this point is f of 2 plus h, correct? Because if you put the value of 2 plus h in our function, you get the value of range, that is f of 2 plus h. Okay, now for these 2 points, that is 2 comma 4. What is 2 comma 4? Let me also tell you that 2 comma 4 is x1 comma y1. And what is 2 plus h? X2. And what is f of 2 plus h? Y2. Right? Great, great, great. Remember, the definition of the function is y is equal to x square. Now let us find the slope. I showed you here the definition of our the method with which we will find the slope. Slope of the tangent is equal to the slope of the limit of the slope of the moving secant as that moving point slides towards 2 comma 4. That is limit of rise upon run as the run approaches 0. And what is the run over here? The run is nothing but the difference between the x coordinates, that is x2 minus x1. Okay, so let's find the slope. Therefore, slope of tangent at point P, slope of the tangent at point P is equal to limit of y2 minus y1 upon x2 minus x1 as, you know what is x2 minus x1? x2 minus x1 is change in x. Okay, so I can write this in brackets. Let me write this x2 minus x1 represents x2 minus x1 represents delta x, that is change in x. And what we need to do is we need to bring these 2 points so close to each other that the difference in their x coordinate becomes very very small, just like this, right? The x coordinate of point Q should be 2.00000001, very close to 2. That is the x coordinate of point P. Okay, so the difference between the x coordinate, which is the run, should approach 0. Run should approach 0 means delta x should approach 0. So limit of the y2 minus y1 upon x2 minus x1 formula, when delta x, that is the denominator, approaches 0, will give you the slope of the tangent at point P. And let's find it out. What we are waiting for, let's find it out. So therefore, limit when delta x tends to 0 of y2 minus y1. Now what is y2 minus y1? y2 minus y1 is f of 2 plus h minus f of 2. Okay, I'm writing in terms of f of 2. Now if you ask me what is f of 2 plus h, it is y2. And what is f of 2? It is 4. Yeah, but it is also f of 2, like, because if you put the value of x as 2 in the function y is equal to x square, you get 4. So why not f of 2? Yes, f of 2 also makes sense upon x2 minus x1. Now what is x2? 2 plus h minus x1. What is x1? 2. Okay, so limit when, now this delta x, we can replace it with h tends to 0. H is the gap between the x coordinate of point P and Q. I told you earlier, right? So that is becoming very very small, infinitesimally small. So this h is tending towards 0. Okay, and f of 2 plus h, can you tell me what is f of 2 plus h? Now see, in this function, in the place of x, see this function's definition, let me tell you very clearly. The definition of this function is y is equal to x square. The definition of this function is y is equal to x square, or f of x is equal to x square. So if the definition of function is f of x is equal to x square, in the place of x, if I put 2 plus h, what will be the answer? What will be the range? It will be 2 plus h the whole square. Whatever is there in the place of x, you square it. That is the definition of the function. Minus f of 2. Now what is f of 2? F of 2 is, you square 2. What do you get? 4. Yes. Upon 2 plus h minus 2, which is nothing but h. Okay. So let's solve this further. Let's solve this limit. So this is a normal limit question, and we know how to solve limits. So limit when h tends to 0 of 2 plus h the whole square, which is 2 square plus 2h plus h square minus 4 upon h. Let's solve this with normal algebraic rules. 4 plus 2h plus h minus 4 upon h. So minus 4 plus 4 gets cancelled. Limit when h tends to 0, 2h plus h square. 2h plus h square. See, h comes out. We get 2 plus h divided by h gets cancelled. Limit when h tends to 0 of 2 plus h is nothing but, see, now h is tending towards 0. So h is becoming very, very small, very close to 0. It is not becoming 0, but very close to 0. And if we ignore h because h is becoming so small, infinitesimally small, then what is the answer of this limit? The answer of this limit is 2. And here what you have is the slope of the tangent at point P. Therefore, slope of the tangent at point P, which is 2 comma 4, is equal to 2, and therefore we can say that dy by dx, derivative of this function y or f of x, is nothing but 2 at 2 comma 4. There you go, we found the derivative. Can you imagine? Now you must be thinking that such a long method for finding derivative. Yeah, it is long method because we are finding using first principles. We are finding using the core concepts of derivative. We are finding derivative using the most, you can say, basic method. So can there be any shortcut for finding derivative? That might be your next question. Yes, there are. There are some direct formulae which we have to learn, and the whole calculus concept will be nothing more than some algebraic concepts. But this is what derivatives meaning is. You got your answer. When you bring point Q closer and closer to point P, such that the secant PQ becomes coincident with your tangent AB, as I discussed in the previous concept, the slope of the tangent AB will become 2. What was the slope of PQ? Initially, I told you in this figure, the slope of PQ was 12. The slope of PR was 8. But the slope at the tangent at point Q, tangent to the curve at point P, sorry, is how much? Actually, it is 2. It is 2. It is not 12. It is not 8. It is 2. Right? So this is the method for finding derivative of a function or slope of a function. Slope of the tangent to the curve at a given point, right? So we found it, we understood the method as well, the first principles. And this is what we did. We brought the point closer and closer till it became coincident with the tangent, and then we found, using the limits, we found the slope. Okay, is there a mistake? Because let me just check once more. They are getting it as 4, right? Okay, 2 square plus, we were having the square of 2 plus h, right? Yeah, there is a mistake. I'm sorry for that. So 2 plus h the whole square is 2 square plus 2 into 2h. 2 into 2 into h, that is 4h. So this is 4h. I'm sorry, that's my mistake. So 4h, here there will be 4. So this will be, okay, let me do it again and show you. This will be 4h, right? So this will be, if h comes out, 4 will remain inside. 4 plus h, right? 4 plus h. So this will be 4 plus h. Now h tends to 0. The slope will be 4. Not 2. I'm sorry. It will be 4. Okay. So now using the same principles, using the same concept, can we find the slope of that real life example which we took of free fall? Can we find the slope, or you can say speed, of a body which is falling down? Yes, we can do that actually. Let me get the graph for you. So you must be thinking that in the previous example which I took, I somehow find the derivative of the function, and how would you believe me whether that is the correct method, or uh, which is the correct method, or yeah, it's right that you think that whatever I'm telling is correct, but no, you should not believe me until and unless I give you a real life example which we have discussed before. That is a free fall. So in this example, I told you that if we find a relationship between the distance, that is height by which the body is falling, and the time which is elapsed, okay, after every second the body is falling this much distance. So that relation we derived to be y is equal to 5x square, where x was the time and y was the distance. And the slope of this graph at any point, slope of this function or derivative of this function at any point, is nothing but the speed, right? So let's find the speed of a freely falling body at a given time using the concept of derivatives which we just applied. Okay, so I've got the graph for you over here. This is the graph of y is equal to 5x square. Let me just write it. Y is equal to 5x square. This is the graph of y is equal to 5x square. Okay, now let's find the speed of a body at 2 seconds. What do you mean by speed of a body at 2 seconds? By saying speed of a body, we have to find the speed of a body at 2 seconds. I mean that we need to find the derivative or the slope of the tangent uh, to this curve at 2 seconds. At 2 seconds, right? At 2 seconds, no, we don't have up to 2 seconds. So we have, okay, let's say after 0.5 seconds, or maybe after 1 second, why not? Okay, so this is, wait, let me figure it out. mm, yes, this is not the point. If we want to find the speed, if we want to find the speed uh, after, let's say, 0.5 seconds, this is the point which we are looking at, because this is where the graph is meeting, this is where the graph is meeting 0.5 on x-axis. So we have to find the slope at this point. Okay, okay, so we have to find the slope of this tangent which I'm showing to you right now. Okay, so this is the tangent, the blue line, which is the tangent at point P. So what is point P? Point P is a point in the whole graph whose x coordinate is 0.5, whose x coordinate is 0.5. Y coordinate we are not bothered about much, so I will keep it as y, but x coordinate is definitely 0.5. So what is the slope of this tangent at x is equal to 0.5? So what is the speed of the body after 0.5 seconds when it is released from any height, any height? Okay, because we know that speed or the rate of change of distance with respect to time does not depend on from which height you are releasing the body. After 0.5 second, it will have the same speed. Okay, so let's see. So slope of tangent at P is equal to the limit when h approaches 0 of f of x plus h minus f of x upon h. That's what we got in the previous example as a formula, right? You remember, this is the formula for finding the derivative or the slope of the tangent at point P. Okay, So let's see. Limit when h tends to 0 of f of x plus h. Now, what is the formula for the function? 5x square, right? So, in this formula, in the place of x, I'm going to put x square. Sorry, x plus h. Okay, in the place of x, I'm going to put x plus h. So, it will become 5 bracket x plus h the whole square minus f of x. Okay, so we have to find the derivative at this point. This is our x, right? So f of x is f of 0.5. Hey, and we will require this point, so we can guess it. We can guess it. This point is exactly between 1 and 1 and 1.5, so it's around 0.75. Yeah, approximately between 1 and 1.5. So that is 2.5, half of 2.5, half of 1 and 1.5, right? So 2.5. So yeah, this is 1.25, not 0.75. I'm sorry, this is 1.25 approximately. I will take this point as 1.25. Yeah, we would require that. So this point y is approximately, and or let's figure it out from the graph itself. I have the graph. Let me figure it out. Okay, so let me just zoom in. Okay, so this point I'm concerned with 1.25. Yeah, it's exactly 1.25. So I'm correct for that matter. Okay, so this will be 0.5 comma 1.25, the y coordinate. Okay, so I've got the x coordinate, y coordinate both. So f of x plus h the whole square, sorry, f of x plus h becomes 5 bracket x plus h the whole square. In the place of x, I'll put x plus h in our definition of the function. Then f of x becomes f of 0.5 upon h. Now h will be h. So limit when h tends to 0 of 5 bracket x square plus 2x h. Now in the place of x, I will put 0.5, right? Because my x is 0.5. So that's one more change I will do over here. Otherwise, it will become complicated. So 0.5. So 0.5 square is 0.25 plus 2 into 0.5 into h, which is 2 into 0.5 is 1. 1 into h is h plus h square minus f of 0.5, which is 1.25, the whole upon h. So limit when h tends to 0 of 5 bracket, we cannot multiply anything over here, right? So let's not. Let's just, we cannot add anything, so let's just multiply straight away. Okay, so 5 multiplied by 0.25 will be 1.25 plus h square minus 1.25 the whole upon h. Minus 1.25 and 1.25 gets cut, so we will be left with limit when h tends to 0 of h bracket 1 plus h the whole upon h, and this becomes limit of 1 plus h, 1 plus h, right, when h tends to 0. So this will become 1. Okay, great. So the slope of the tangent at point P is 1. That means the speed of a body after 0.5 seconds of falling is equal to 1 meter per second, is equal to 1 meter per second. And this speed will go on increasing. This speed will go on increasing at the rate y is equal to 5x square. So we can find the speed after any particular interval of time. Okay, let's take another example in the same thing. Let's find the speed of body after let's say 5 seconds of falling. After 5 seconds of falling, so we should know the distance after 5 seconds, right? We can find the distance now. We can find the distance from this formula. So if the time is 5 seconds, the distance will become y multiplied by y is equal to 5 multiplied by 5 square, that is 5 multiplied by uh, 25, which is 125. Okay, so let me write it. Speed of the body after 5 seconds, we are finding this thing. Okay, so we know that x is equal to 5 and y is equal to 5 into x square, that is 5 into 5 square, which is 5 into 25 or 125. So x is your distance, and sorry, x is your time and y is your distance. Okay, now the speed of the body after 5 seconds. How we'll find the speed? Speed of the body is nothing but tangent of the curve, tangent to the curve, or tangent of the curve, slope of the tangent to the curve. I'm sorry, slope of the tangent to the curve at x is equal to 5 seconds. At x is equal to 5 seconds. So slope of the tangent to the curve at x is equal to 5 seconds is equal to speed of the body at 5 seconds. That's what we need to find, not after but at. Okay, which is equal to limit when h tends to 0 of f of x plus h. Now your x is 5, so 5 plus h minus limit of, sorry, minus f of 5 upon h. That's it. So limit when h tends to 0 of, in our function's definition, that is y is equal to x square, y is equal to 5x square, we need to put in the place of x, we need to put 5 plus h. So 5 bracket 5 plus h the whole square minus f of 5. F of 5 we already know is 125 upon h. Let's solve this. So this becomes limit when h tends to 0 of 5 bracket 25 plus 2 into 5 into h, that is 10h plus h square minus 125, the whole upon h. Okay, so this becomes limit when h tends to 0 of 125 plus 10h, sorry, 50h, 5 into 10h, 50h plus 5h square minus 125, the whole upon h. So we have minus and plus 125, which will cut, and limit when h tends to 0 of, now see over here we are going to take 5h common. If we take 5h common, inside will be left with 10 plus h, the whole upon h. H gets cut. Okay, so limit when h tends to 0. Okay, this 5 gets multiplied inside, 50 plus 5h. Now see, h is tending towards 0. H is becoming 0. So 5h will also become 0, right? So the answer is 50. 50 meter per second. So what is 50 meter per second? 50 meter per second is the speed of the body at 5 seconds. You remember the initial answer? The initial question, I'm sorry. The initial question was speed of the body after 0.5 seconds, and it was 1. And speed of the body at 5 seconds was 50. So the speed of the body is continuously increasing, right? So yeah, this is how you use derivative to find the slope of the function. Okay, now few more things and then we'll directly go uh, to the formulae, to the methods using using to the formulae using which you can find the derivative of a function directly without doing all this slope or limit or whatever. Okay. So there are three cases where the derivative does not exist. You must remember these three cases. Number one, there is no tangent line and there is no derivative of any type at any type of discontinuity. Okay, so if there is a discontinuity, that means there is a hole in the graph of the function, there is a gap, then there does not exist any tangent and you cannot find derivative at this point. Okay, second, there is no tangent line and thus no derivative at a sharp corner of a function. Do you see this cusp or the sharp corner? At this point you cannot find the derivative. Okay, and third, where a function has a vertical inflection point. Okay, see, this function has a vertical inflection point where the tangent line becomes vertical and you cannot find the slope of this tangent line. It is infinite. The slope is infinite. That means the derivative cannot be found. It does not exist at these two instances. And the third instance is where, if I draw it for you, let me draw it for you. The third instance, suppose you have a graph which is like this. Okay, here and here, you see, it's a single you can say domain at which there is a, at a single point of x, there is a gap here, so there is a discontinuity. So at x you cannot find derivative because there is a discontinuity in the function. Okay, which we discussed in the limits part also. So these are the points at which we cannot find the derivative. Okay, now in the next topic we are going to use some rules of derivative and directly apply the rules and find the derivative without considering the graph. There is no graph, nothing, directly apply the rules and find the derivative. Let's do that. Okay, so in this part, we are going to study about the rules of differentiation. See, we were finding the derivative or differentiation of a function, uh, basically slope of its tangent at a curve at a point, but it was a very, very long method. But since now uh, we are just concerned, or we are just focused on finding the derivative of a function directly using some algebraic methods, as we know the basics behind it, as we know what we actually do or what derivative actually does for us, so we can directly use some ready-made formulae for finding the derivative. Okay, so the first formula is the constant rule. So derivative of a constant is 0. Let's list the formula. Okay. Now the symbol for derivative, let me tell you, is d by dx of y, or dy by dx, or sometimes written as f dash c. So derivative of a function y, or dy by dx, or derivative f dash is also derivative of a function at point c. These are all the symbols with which a derivative is known. So the first rule says derivative d by dx of a constant, c means constant, is 0. Derivative of a constant is 0. I want you to note down all these formulae because when you find the derivative, I don't want you to do the limit method. I want you to directly apply the formula. Second rule is the power rule. So power rule is somewhat like this. Let me show you. D by dx of x raised to a, or let's write x raised to n. D by dx of x raised to n is equal to n multiplied by x raised to n minus 1. So what you do is you take the power, multiply in front of the whatever expression you are getting, and then multiply that n, that is the original power, with x raised to n minus 1. So you just multiply the original power with x to the power n minus 1, that is 1 less than the original power. You just multiply n with x raised to 1 less than original power, that is x raised to n minus 1. So suppose, for example, you want to find the derivative of x cube. So it is simply 3x raised to 3 minus 1, that is 3x square. The derivative of x cube is 3x square. Simple, right? So that is the power rule. Okay, the next rule is, okay, the power rule works for positive, negative, fractional power, whatever power you have. Power rule always works. Okay, always remember. Okay, multiple rule. Constant multiple rule. Let me show you what is that. The third rule is constant multiple rule. Suppose you have d by dx of a into x raised to n, or a into x, anything. Okay, so then it will become a multiplied by d by dx of x raised to n. So what happens with the constant which is multiplied with our algebraic expression? It just comes out of the derivative. Okay, so you get a multiplied by x raised to n minus 1. That's it. So if there is a constant, for example, let's say we want to find derivative of 4x cube. So it will be 4 multiplied by the derivative of x cube, which is nothing but 3x square, right? 4 multiplied by derivative of x cube, because 4 comes out of the derivative, and derivative of x cube is 3x square. We just did it here. So 4 into 3x square, that is 12x square. Simple. Let's go to the next rule. Please note down all these rules. Okay. Okay, sum and difference rule. So sum and difference rule is simple. So basically, when you want to do sum and difference rule, you just distribute the derivative over sum or difference. Okay, you just distribute the derivative over sum and difference. That's it. So if, let's say, you want to find d by dx of x plus x square, it is simply d by dx of x plus d by dx of x square, right? So d by dx of x is nothing but 1. Always remember, that's one more rule. That's one more rule. Now that is very much related to the first rule, because here the power of x is 1. So you write 1 into x raised to 1 minus 1. 1 into x raised to 0, which is nothing but 1. So derivative of x with respect to x is 1. The rate of change of x with respect to x is always 1. It was always constant. Okay. So derivative of x is always 1. That is okay. Plus derivative of x square. So this will become 2x. So the answer is 1 plus 2x. Similarly, if you have got minus sign, that is derivative of a difference, let's say x minus x square, that is derivative of x minus derivative of x square, which is 1 minus 2x. Easy? Easy? Great. So we have sum and difference rules. Then we have derivative of trigonometric functions. And for finding derivative of trigonometric functions, you simply have to remember these 6 derivatives. Derivative of sine function, sine x is cos x. Derivative of cos x is minus sine x. Derivative of tan x is sec square x. Now you must be wondering, how did they find these derivatives? It is simple. What you do is you use your first principles, that is your limit wala method, the long method, and you can find the derivative. Derivative of cosec x is minus cosec x into cot x. Derivative of sec x is equal to sec x into tan x. Derivative of cot x is equal to minus cosec square x, etc. Right? Make sure you memorize the derivative of sine and cosine. And for according to me, you should memorize all these six derivatives. Exponential and logarithmic functions. Always remember the derivative of natural exponential function e raised to x is e raised to x. That's very easy, right, to remember. Okay. What about the derivative of natural log? Derivative of natural log, that is log to the base e of any number, is just reciprocal of that number. D by dx of ln x is equal to 1 by x. Okay. Then there are product and quotient rules. Product rules and quotient rules. So suppose you have two functions in product with each other, in multiplication with each other, or you can say two functions in division with each other, then how to find its derivative? So this will be helpful. See, suppose you have something like this: y is equal to x cube into sine x. So y dash, that is derivative of this whole function, is derivative of the first function multiplied by the second function plus second function into derivative of, sorry, first function into derivative of the second function. Okay, so this is the product rule. And if you have three or more terms in the product, then there is one more term added over here. So there will be a plus sign and there will be one more term added. But if you have a quotient rule, and in quotient you have numerator and denominator. So the derivative of this quotient, of this fraction, is derivative of the numerator multiplied by the denominator minus numerator multiplied by the derivative of denominator upon the denominator square. Okay, so let me write this for you in a, you can say, general form, so that you can remember it. Okay, and I will call it product law. Okay, so product law. Okay, before product law we studied, I think we studied the derivative of two more functions. The derivative of e raised to x is e raised to x, and the derivative of log of x to the base e is 1 by x. Okay, yes, we have also studied the derivative of trigonometric functions, that is d by dx of sine x is equal to cos x. I'm sorry, there should not be any equal to sign here. So d by dx of sine x is cos x, then d by dx of cos x is minus sine x, derivative of tan x is equal to sec square x, derivative of sec x is equal to sec x tan x, and derivative of cot x, we didn't take that, cot x is minus cosec square x, derivative of cosec x is minus cosec x cot x, right? So these we studied. These are the normal rules of derivative. 12 formulae till now. 13th formula is power law. Sorry, product law. I'm sorry. Okay, so suppose we have derivative of f of x multiplied by g of x. So what is f of x and g of x? These are two functions. So they are in product with each other, multiplication with each other, and we have to find derivative of this product. So the product law says that derivative of the first function, that is f dash x, I will write it f dash x, that is derivative of the first function, multiplied by the second function, that is g of x, plus the first function, that is f of x, just a moment, f of x multiplied by derivative of the second function. Okay, multiply by derivative of the second function. So that is your product rule or product law. Then there is quotient law. Okay, so what does the quotient law says? Suppose we have d by dx of f of x by g of x. Okay, so f of x by g of x, suppose we have, then we get f of x is the numerator, so we first find the derivative of the numerator and multiply it with derivative of the denominator minus numerator, the function in the numerator, multiplied by derivative of the denominator. So g dash x upon the whole upon square of the denominator, that is g of x the whole square. This is the quotient law. Okay, so let's take an example of each to understand. Okay, so suppose we have a function, let's say y is equal to x raised to 4 multiplied by sine x. Okay, and we have to find dy by dx, that is derivative of the function y. Now as you can see, there is a product of two functions. X raised to 4 is one function and sine x is another function. So we will use product law. So dy by dx will be equal to derivative of the first function, that is x raised to 4 multiplied by second function sine x, plus the first function multiplied by derivative of the second function d by dx of sine x. Okay, so this will become 4x cubed multiplied by sine x. This will become x raised to 4 multiplied by cos x, right? The derivative of x raised to 4 is 4x cubed. Sine x remains sine x. The derivative of sine x is cos x and x raised to 4 remains x raised to 4. So this will become 4x cubed multiplied by sine x plus x raised to 4 multiplied by cos x. Nothing can be done to this. This is the final answer. But suppose we have a function which says that sine of x upon x raised to 4. So we cannot apply product law. We can apply quotient law over here. So what is the quotient law? Quotient law says that first dy by dx, you will get the derivative of the numerator, derivative of the numerator, that is d by dx of sine x multiplied by denominator, that is x raised to 4, minus uh, numerator multiplied by derivative d by dx of denominator x raised to 4, the whole upon uh, x raised to 4 the whole square, denominator square, right? So what is the derivative of sine x? It is cos x multiplied by x raised to 4 minus sine x multiplied by Derivative of x raised to 4 is 4x cubed, correct? The whole upon x raised to 8. Now you can take out something common from the numerator and denominator. Numerator, basically x cube, and inside you will be left with x cos x minus 4 sin x, x cos x minus 4 sin x upon x raised to 8. This x raised to 8 and x raised to 5 will cut, and you will get x raised to 5 over here. So this is how you use quotient rule and product rule both. I'm going to give you some some homework for on the based on this. Okay. Okay, there is one more rule which is chain rule, but for going deeper into chain rule, we will need some more practice of the basic rules. So I will end this video right here before I go ahead into chain rule and explain you how to find the derivative of a chain rule using chain rule of function of a function basically. So that will take a little time. But in today's class, we understood, in today's video, we understood what is derivative and what is the actual meaning of finding derivative of a function at a point, how it is related with the slope of the tangent to the curve at a point, and how to find it using limits, and how to directly use formulae which we just saw, and apply these formulae and directly find the derivative of a function at a point. So this much information should be enough. The video has become a little longer, but it's okay. Now we are not left with much topics. Maybe a chain rule video from of derivative, and then integration basics, and the formula of integration. Right. So that will take a couple of more videos, and we'll be done with basic calculus. Okay. So see you in the next video. Bye bye.